A, D, E, and K are the fat-soluble vitamins, and they will differ from water-soluble vitamins. First of all, we know they're insoluble in water. They also require biles to be absorbed. Once they're absorbed, they're going to travel through the lymphatic system as part of chylomicrons, which is a term you should remember when we talked about fat digestion and absorption. They travel through the circulatory system to get to the liver, where they're processed. Then they enter the circulatory system, where they are attached to carrier proteins. They are stored primarily in the liver and in adipose tissue. We maintain normal blood concentrations of all of the fat-soluble vitamins. They're pulled out of storage as you need them, so you can actually eat less than your daily requirements for months or sometimes even years without deficiency issues. In general, we really only need to consume enough of these guys that your average daily intakes is about the same as the approximate recommendations. Because these fat-soluble vitamins are not excreted too terribly readily, the risk of toxicity is higher for fat-soluble vitamins than for water-soluble vitamins. So let's start with vitamin A and beta-carotene. And this guy was the first fat-soluble vitamin to be discovered and then researched. So the precursor to A is beta-carotene, and they have a lot of roles in a whole bunch of different aspects of physiology. There are 3 forms of vitamin A that are active: retinol, retinal, and retinoic acid. Foods that come from animal products provide the building blocks that are easily converted into retinol within your small intestines. Foods from some plants provide carotenoids, which have some vitamin A activity. And this vitamin is pretty versatile. If you've ever heard, oh, if you eat a lot of carrots, you're going to improve your vision, that's true to a certain extent, because there's a lot of vitamin A in carrots. So it does play a major role in vision. You need it for protein synthesis. You need it for the differentiation of cells. And you need it to be able to reproduce and grow the cells, and therefore your organism. We talked about how important it is in vision. It helps keep your cornea lovely and crystal clear. It's going to be required for the chemical conversion of light into action potentials within the retina. The visual activity actually triggers continuous tiny little losses of retinal. So you need to replenish this fairly constantly. Replacement retinol comes from stored retinol in adipose tissue and the liver, because that is where fat-soluble vitamins are stored. So when you talk about the cells that are actually lining your body surface, as well as the organs within you, vitamin A is going to be important because you need it for protein production, as well as cell differentiation. It will help increase cell differentiation or promote cell differentiation in epithelial cells. Think cells of your skin, cells of the lining of your mouth and your intestines. And it's also going to be important for goblet cells. Goblet cells are going to secrete mucus, which you're going to find that you need throughout your entire digestive tract. I know we've spoken about that. A is also going to be important because it plays a role in both reproduction and growth. In males, you need retinol because it's going to be important to sperm production. In females, it's going to help support normal fetal development. If you're deficient Really, the status of vitamin A is going to depend on the amount that you've stored in the body. About 90% of vitamin A are going to be stored in the liver. Vitamin A status will depend on your protein status, because the retinol binding protein actually needs to be present as a transport carrier. If you don't have the appropriate binding protein, you're going to be deficient in vitamin A. So if somebody stopped eating vitamin A rich foods, you won't have any sort of symptomatology around deficiency for up to 2 years in healthy adults. Children tend to demonstrate symptoms faster because they demand way more for faster growth, and that should make sense. So if you are deficient, you're more at risk for infectious diseases. Night blindness is a big problem in terms of deficiency, and it's the first detectable sign of vitamin A deficiency. If you leave this untreated, total irreversible blindness can occur. It is rare. This happening is rare in developed countries, but it does occur in poorer, less developed areas across the world. So it can also end up with highly keratinized skin. So basically you have this rough, dry, and scaly skin, and it actually weakens your outermost protective layer because your skin acts like a baggie to keep stuff that's not supposed to be in it, like viruses, bacteria, other pathogens, out. Additional symptomatology of deficiency of vitamin A is you might have an impact on your respiratory system. You might have some funky, wonky gastrointestinal occurrences, sometimes diarrhea, sometimes constipation, as well as it's going to play a role in your immune system defenses. So you need vitamin A to help keep a robust immune system. Toxicity. Generally, they start to develop when the binding protein for A becomes overwhelmed, and free vitamin A will start to damage your body cells. Beta carotene is not converted terribly efficiently within the body to reach toxic levels. And it's going to be found in a wide variety of fruits and veg, including carrots. Overconsumption of beta carotene, in other words, if you're eating a lot of carrots, you can actually get your skin to turn yellow or yellowy orangish. It's not harmful. You can actually overconsume beta carotene from vitamin supplements. If you take it in excess, vitamin A and activated beta carotene may act as a pro-oxidant, not an antioxidant. So watch that video on what is hypervitaminosis A. Toxicity can trigger birth defects. So excessive intakes can cause problems with your fetal development. And that shows you that women who took more than the appropriate IU, international units, of supplemental vitamin A had an increased risk of developing fetal growth issues. So they've done a bunch of studies, and in one of them, about 1 out of every 57 infants was born with a malfunction that was directly attributable to vitamin A toxicity. It's particularly damaging if you are consuming excessive amounts before the 7th week of fetal development. And you shouldn't be taking vitamin A supplements during the first trimester of pregnancy unless there is evidence of clinical deficiency, and those are rare. That shows you the RAE, and the body can actually convert vitamin A from these retinoids and carotenoids. So we have these retinol activity equivalents. for vitamin A, specifically for vitamin A. There's where it's found in terms of retinol. Beta-carotene is going to be found in deep orange fruits and veg, carrots, dark leafy greens, and broccoli. Watch that vid on vitamin D. Now, changing directions here because vitamin D is going to be different from all of the other fat-soluble vitamins because we can actually synthesize it ourselves. You need to have exposure to the sun and expose or create a molecule that's pulled from or made from cholesterol. You can make your own vitamin D. So it's not an essential nutrient. So if you spend enough time in the sun and are reasonably healthy, you can survive with no vitamin D from the foods we consume. Now, did we evolve taking showers once a day, sometimes twice a day? No. People might have jumped in ponds or lakes or streams or rivers a couple of times a year in the spring and in the summer if it got too hot, but we did not evolve taking showers. So there are actually oils on your skin that get washed away when you are showering. Those oils are important in developing appropriate amounts of vitamin D. So just as an FYI, I'm not saying don't shower for weeks at a time. I'm just giving you a heads up. The other issue with synthesizing vitamin D is, I don't know about you, but when I'm out in full sun, I am slathering sunscreen on. When you slather sunscreen on, you cannot produce appropriate amounts of vitamin D. You cannot, because the ultraviolet waves are blocked. So my dermatologist tells me twice a year, avoid the sun, put on a lot of sunscreen. And to develop a healthy skeleton, you actually need exposure. Help to develop and maintain a healthy skeleton. Cheapers, you actually need exposure to the sun. Double-edged sword. So we have these two reactions that have to occur before the vitamin becomes fully active and available for use for physiological reactions. Your liver has to perform a chemical reaction that adds what's known as an OH group, that's hydrogen and oxygen. And then your kidneys add another OH group that's going to activate the vitamin. If you have problems with your liver or your kidneys, you can actually interfere with the activation of vitamin D and you can end up with a deficiency. And this is just a little chart which helps walk you through how we make vitamin D internally. And I'm not going to ask you the names that are in those boxes, just telling you that the skin can make it or plants can make it. Then you consume those plants and you get it in your diet. It's actually a hormone. It's going to be really important for synthesizing and maintaining bone growth because it will also help maintain blood concentrations of calcium and phosphorus, which are ions you need for bone health. Vitamin D is going to raise the concentrations of minerals in the circulatory system by enhancing mineral absorption in small intestine, mineral reabsorption by our friends the kidneys, and mineral mobilization from the bones into the blood. Because yes, you will break down your bone in order to get calcium if need be. These are the other target tissues for vitamin D, and you can read through all of those. So you can see that it has a lot of functions. Rickets is a vitamin D deficiency. You have failure of your bones to calcify normally, which means that your bone growth is going to be affected and you will end up with skeletal abnormalities. The bones of the lower extremity, your legs, become so weak that they actually bow or bend when they're supporting the body's weight. kid who has rickets generally develops bowed legs and bowed arms. So a couple of conditions. Osteomalacia is the adult form of rickets. Osteoporosis is more severe because you're actually losing calcium from bones. You're decreasing your bone density, which means you can trigger fractures. It's more common in women because of the incredible need for calcium for fetal development. I am sure you've heard the statement, I fell down and I broke my hip, for people who are osteoporotic. It is actually the other way around. The hip was so fragile that it shattered and the person fell down. If you're talking severe osteoporosis, that's what happens. In the older you get, so in geriatrics, you're going to have slower and lower both liver and kidney functions. So you might end up with vitamin D deficiencies. Toxicity, you end up raising concentration in the circulatory system. If you consume too much, it'll actually leave the blood and get deposited in soft tissues like muscle. And if that happens, you can actually have calcified calcium or kidney stones or gallbladder stones, gallstones. And calcification actually may also harden your blood vessels, which may be associated with a cardiovascular incident and therefore premature death. Sheesh, can't win. There are your sources. The sun. And we talked about sunscreen. If you're out a lot with sunscreen on, you may need additional supplementation. Vitamin A is also an antioxidant. It's one of the primary defenders against free radicals. So it helps protect vulnerable parts of cells and their membranes from destruction from free radicals. Again, it sacrificially destroys itself, sparing the cell organelles. How noble. Vitamin E also may help reduce problems with heart disease because it protects transporters for proteins. A little video on vitamin E. Deficiency occasionally happens in premature infants because if the infant is born before vitamin E is transferred from the mother, the child may end up with erythrocyte hemolysis. If you have an extended deficiency of vitamin E, you might have neuromuscular dysfunction. And that might affect the retina of the eye and spinal cord. There is a fancy term for intermittent leg cramps, which is known as intermittent claudication. So if you're deficient, you might have that intermittent claudication. You might have weakness, and you might have difficulty walking. Toxicity, pretty rare. You have to consume really high doses to interfere with blood clotting. And vitamin K is, anytime you hear K, think blood clotting. High doses can enhance the effect of some drugs. So you got to be careful when you're consuming this because people who are on blood thinning medication may develop uncontrolled bleeding. So caution, right after hemorrhage. There are your recommendations. There are your food sources. K, you hear K, think clotting. This is going to be associated with the cascade for producing blood clots. It's also going to be associated in the synthesis of proteins in the skeletal system. And If you have insufficient K, you're going to produce an abnormal protein that doesn't bind to minerals that you need to form bones. And you may have bone density issues because of it. Significant vitamin K deficiencies are associated with uncontrolled hemorrhaging. And we've already talked about bone density issues and skeletal weakness. Toxicity, pretty uncommon. Mostly occur, but not always, when you're prescribed and consume vitamin K supplements, especially if you're talking about infants and pregnant women. You might have red blood hemolysis, you might have jaundice, you might have brain damage. If you are on an anticoagulant medication, you have to use caution in taking vitamin K. Those are the sources, and those are the foods. And guess what? The normal flora in your large intestine actually produces vitamin K. Pretty cool.